what makes electricity flow, right? That is commonly known as the electron. So let's dive a little deeper into the electron and the nature of a point charge, right? So we understand now, before we get into this, right, the basics, we know that all atoms, proton, neutron, electron, and we also know protons and neutrons are huddled up, very, very, very close, very tightly knit together in the nucleus, right? So these guys are comfy. However, the electrons are always, just flying about the nucleus, depending on what model of atom, obviously, you like to choose to look at. They're flying about, and every atom has the set of valence electrons. So valence electrons are the electrons on the very last shell of any atom. Now, these electrons tend to be mobile. That means they can easily be knocked out, and one can easily be added in, right? Depending on the number of valence electrons they have. And almost every single atom has this configuration. The only ones that this doesn't really apply to are the noble gases, right? Because those have 8 valence electrons, and those guys are good. They don't want any. They don't want to let go of any, right? Now, when we come to other atoms, such as copper, silver, and stuff like that we're gonna be talking about, these guys, their electrons can be moving, right? They're free to move. So the advantage of that is when you put a lot of these atoms together and you knock one electron off, just one, it starts this chain reaction between all of these atoms that basically continuously knock these electrons off, and basically what we call the flow of electrons, right? So again, even before getting into like the whole charge and that understanding, this was, I think, a very simple explanation of what is electricity, right? So when we put these atoms together and these electrons from the last shell of these atoms are just flying together, right? So one is going to another atom that kicks the electron to the next one. Mm-hmm. So the next one kicks the electron to the next one. And it just keeps going like that until there's, one side and the other side, right? And then there's flow of electrons, which is what we call electricity.
And I'm going to use this analogy in like a couple of minutes, but it's pretty useful to think about the flow of electricity just like the flow of like a liquid. Because, it is like just electrons moving along, right? But if you look at it on like a macro scale, you kind of zoom out a little bit, it is a lot like fine grains of sand, like so fine that it's pretty much like a liquid, and I'm going to use this later on when we talk about conductors, but yeah, about it. Mm-hmm. So the very first thing that you learn in electricity is the point charge, or I think you can call it like the test charge or something. Mm-hmm. But there's two, right? There's a positive and there's a negative. By convention, it doesn't matter what you really call it, but we said that the electron has a negative charge, and we say that like the electron has like 1 unit of like negative charge, right? The actual charge is like what, like negative 1.612
10 to the negative
times 10 to the negative 19 joules. Mm-hmm. But that's just like, the SI value.
Unit, exactly.
When I think about an electron, I think of like 1 unit of like negative charge. Mm-hmm. And
so that would just be electron. I mean, I don't want to. Okay, the electron volt. I thought you were gonna like kind of come into that. I don't want to.
Yeah.
Sorry. Continue.
Well, I was gonna say like there is a unit called the electron volt where it, as Rehan said. But the point is that there's a positive and there's a negative. And I love, every time I talk about electricity and electrostatics, I love making the connection to gravity, because okay, you have, in electrostatics, you have positive, negative, and opposites are attracted to each other. And the equals, if you have 2 negatives, they repulse. 2 positive, they repulse. And you can set up problems where, you have a positive and a negative that are attracted to each other. And the thing is, you can kind of mix your knowledge of like gravity dynamics and also electrostatics, because we had this one problem on our first year, our first year physics exam, the second semester, where it was like, imagine you had a planet that was donut shaped, and then there was a moon on like the axis of the donut that was oscillating back and forth through the donut hole. And the way that I solved this was, I thought of the gravitational field of the donut as an electric field and how it was affecting a charge moving back and forth. Because essentially this wasn't a gravitation question. This was an electrostatics question. I guess you can call it electrodynamics, but I think I used Gauss's law, but you just replace the constants and it all works out the same. And yeah.